Welcome everybody to the law of cosines. We've been looking at right triangle trigonometry, started off with SOHCAHTOA. We did some law of sines, took a look at an ambiguous case, talked about side-side angle. Today we're going to do the law of cosines. Again, used in triangles that are not right triangles, finding missing sides and missing angles. And the law of cosines is helpful when you know all three sides or two sides and the included angle. So here are the formulas. And here's going to be our first example. It is a side angle side example. If we draw a picture, we can go A, B, C. We can say capital A is 30 degrees, lowercase b is 10, and lowercase c is 20. You can see that the included angle means it's touching both of the given sides. So if we want to find side A, that's a bad A, isn't it? We can use the formula. B squared plus C squared minus 2BC cosine A. And we're just going to plug it into our calculator. So we're going to have the square root of 10 squared plus 20 squared minus 2 times 10 times 20 times the cosine of 30 degrees. And all of that is underneath the square root. So if you grab your calculator, you can type all that in. And I don't know why, but I like to do the square root at the end. So I'm going to do 10 squared plus 20 squared plus 2 times 10 times 20 times the cosine now, law of cosines. It was 30 degrees. And I got 846, and I've got to take the square root of that. And that's going to give me side A. It's pretty close to 29. Okay? And now I want to find a missing angle. I'm going to go and find angle B. And we've got a formula that says cosine of angle B is A squared plus C squared minus B squared over 2AC. So if we put in our A is going to be 29 squared, and our C was 20 squared, minus B is 10 squared, over 2 times A times C, 2 times 29 times 20. Now, what I do to remember the formula, everybody, is I know that B is the angle I'm finding, so the side opposite is the one that I put last. Really, these two wouldn't matter. And another little thing that I like to do is actually calculate the denominator first, 2 times 29 times 20, and then do the numerator second. It's just nice to have on my calculator. So the denominator, 2 times 29 times 20, is 1160. And I can put that right down there. And then 29 squared plus 20 squared minus 10 squared. 29 squared plus 20 squared minus 10 squared gives me 1141. And now I know that the cosine of B is 1141 over 1160. And so to find B, I'm going to do the second inverse cosine of that again. So we'll pull up my calculator, and I need to take my answer, 1141 divided by 1160, and I get that decimal. And if I do second cosine, notice it's the law of cosines of that answer, I'm going to get that angle. And it's about 10.4 degrees. So angle B is about 10.4. That means angle C, 30 degrees and 10 degrees is 40 degrees. This is about 140 degrees, 139.6. Remember, they add up to 180 degrees. So I took the 10.4 and the 30, we got 40.4, and subtracted that from 180 to get my angles. And you can see the law of cosines, pretty friendly formulas. There's no ambiguous case. How nice is that? So you do not have to worry about that. And let's give you another problem. Your favorite thing in the world, a word problem. If you take a look at just the picture, you've got some hot air balloons. They're approaching a landing field, 12 meters and 17 meters from the landing point. The angle between them is 70 degrees. How far apart? So I think you would all agree we want to find this side. That's the dashed line. And I think you would all agree that we have side, angle, side. Now the thing is, you could try the law of sines. You would not have enough information to solve. So if you ever forget which one to use, try the law of sines. And if it doesn't work, try the law of cosines. I would call this triangle, just to keep it simple, A, B, C, because then I'm finding side A again. And side A is the square root of B squared plus C squared minus 2BC times the cosine of angle A. So this time I'm going to type it all in at once. B squared is 17 squared plus 12 squared, 2 times 17 times 12 times cosine of 70 degrees. Make this so you can read it a little bit better. And we'll see if we can remember all that and type it into our calculator. 17 squared plus 12 squared minus 2 times 17 times 12 times cosine 70. There's no way I can remember all that. I've already forgotten. 17 squared plus 12 squared. So second square root 17 squared plus 12 squared minus 2 times 17 times 12 times the cosine. I've seen people put in sine here, and I think it was 70 degrees. And the answer is about 17.1. So again, nice, similar formula to use. They're about 17.1 meters apart. And there's just a couple of examples for you. Let's see what else we have here. Solve this triangle. All right, so this one, we've done side, angle, side. Let's do a side, side, side. You could draw the picture again, and again, I would recommend it. Remember, it doesn't matter where you put A, B, and C. A is 22, B is 20, C is 18. You can see I obviously need some sides. I know all the sides, so I'm going to do the angles. So I'm going to do the cosine of A, and it's going to be, so this is how I remember it. Side A is going to be subtracted, so it's going to be 20 squared plus 18 squared minus the 22 squared. Again, you don't have to memorize the formula, so you don't have to do this, but when you get old like me, you're looking for little shortcuts. 2 times 20 times 18. And again, I do the denominator first, then do the numerator divided by the denominator. Remember, this is going to be what the cosine of A equals. So 2 times 20 times 18, we could probably do that in our head. 2 times 20 is 40, times 18 is 720. Let's move that over a little bit so we can see it. 720. And then we're going to get the numerator, 20 squared, 18 squared, minus 22 squared. 20 squared plus 18 squared minus 22 squared. It's going to give us 240. So then we're going to do 240 divided by 720. Those of you good at math, you know it's 1/3. Now we can fill this in. 240. So we know the cosine of A equals 0.33 repeating. A is going to be the inverse cosine. Put that calculator back. Second cosine second answer. And we know angle A is about 70.5 degrees. I am not going to do angle B or C because I think you could do it. I know you can just set it up. You do the same kind of thing. Side, side, side. There you go. Do we have a slide here for you? I think I do. There it is. When should I use the law of sines and the law of cosines? Consider the parts that you know and the measurements you know. Law of sines is side angle is the ambiguous. That's the only time, you guys. People get hung up on that. They always have to try this. And really, you were rarely going to have to try it. It only is during law of sines and side angle when you have to worry about no triangles or two triangles. If it is not law side angle, you know it's going to be one triangle. Law of cosines, always one triangle. So the majority of the time, you only have one triangle. So, kind of nice. If you have two angles, it's going to be law of sines. If you have one angle, people get confused between side angle and side angle side. So I'm going to draw one of each here. This is side angle side. Notice the angle touches both sides. Here's another way to do it. You can do side angle side. Here's another way to do it. Side angle side. Notice they're right in a row. Side angle side. The ambiguous case is side angle. The angle does not touch both sides. Again, you can do that in different ways. Side angle. Also spells that naughty word back. But that is another point. Super important to keep your life as simple as possible. And that you don't have to keep trying more and more problems. Here is one last problem for the law of cosines. Another real life word problem. You want to find out how wide the pond is. Okay? So, let's see how this shows up. There's going to be my distance. I'm going to call this lowercase a to keep it simple. This would be ABC. Again, you can go around ABC. It doesn't matter. And I want to find side A. And it's going to be the square root of B squared plus C squared minus 2 times 131 times 152 times the cosine of 45 degrees. And here's a nice thing to have that TIE for. You can just type it in like that. And that's going to tell you how wide the pond is. We're going to type it in. 131 and 152 are my numbers. Let's see how I do on remembering this. 131, oops, I didn't do square root. I'm going to start over. Second, square root 131 squared. And was it 152? I'm just going to check quick because I often forget. It is 152. Minus 2 times 131 times 152 times cosine 45 degrees. And that's how wide the pond is. 110. Is it feet? It is feet. It is about 110 feet. Nothing to it. Law of cosines. Side, and side angle side. Law of cosines. Never. Ambiguous case or the possibility of two triangles. Who doesn't love the law of cosines? Thanks for your attention.